All right, so now we're going to talk about visualizing our correlations. We've gone over some basic correlation terminology in terms of if it is a positive or a negative correlation and what we mean by saying that it's a correlation, meaning that there's a relationship. But then also, are we allowing room for the possibility that there are some confounding variables or extraneous variables or third factor variables? So now we're going to talk about visualizing correlations. So I've put up some pretend data. This is not data from anyone in any of my classes. But let's say we were to put together a graph and we were wanting to show the amount of time you spent studying for the last quiz and your percentile score on the last quiz. So I've put time studied down here on the x-axis in half-hour increments going from half an hour to 4 hours. And I've put the scores possible from 10% to 100%. So let's say I went through and plotted these scores. And the way I have this set up, I realize it's a little blurrier than usual. I'm not sure what's going on with my webcam. But the way I have this set up, let's say I had 3 students who said they studied for half an hour. One got a 40%, one got up here what's looking like probably about a 48, 49%, and one got right at 50%. I had 2 students who said they studied for an hour. One got a 55, one got about a 65. Students for an hour and a half, there were 3 of them. One got a 60, one got a 65, one got a 70. All the way up until these 4 students who studied for 4 hours were all like 95 to 100%. So let's say I'd gone through all the scores in my class, asked everyone, hey, how much time did you spend studying for this quiz? And plotted all this out. If I have a linear correlation, which is what I have here, if I have a linear correlation, what I'm going to be able to do is look at my hash marks of my scores. And I'm going to be able to find a spot on this where I can draw a line that makes sense with my scores. I can draw a line that fits well. This is a linear correlation. And just for practice, since we are seeing as the time increases, the score increases, as the time decreases, the score decreases, what kind of correlation is this? It's a positive correlation. So with a linear correlation, we are not saying that all the marks have to fall exactly on this line. We are saying that this line is a good representation of the general trend of our scores. So let's say we had this and there was still, maybe there was a student down here who studied an hour but only got a 30%. Maybe there was a student who studied an hour and a half and got 100. So maybe these are further scattered out. You can see I can still scatter them a little bit. Let's have it like that. They can still be scattered out a little bit, but that line still makes sense, right? This is still accurately representing the general trend that the scores are moving. Now, if I had a bunch of stuff down here, let's say I had some of this filled in down here like this. Now it's maybe more of a stretch to have that line going that way, especially like if I erase some of these and maybe I add some more scores with low study time, high score. If I had something like that, I couldn't show you this and say, hey, look how well my line fits, right? Because I now have all of this down here and all of that up there, and that no longer is a fair estimate. With correlations, we measure the strength of it. Now, whether or not it's statistically significant has a lot to do with the power of your study and all that. But our actual correlation coefficient that we calculate, which is always portrayed as R, if we're doing a Pearson's correlation, it will always be R equals. If you're doing Spearman's rho, which is another one that your textbook talks about, we use A rho. But the majority of the time, you're going to see correlations marked as R equals. So our R equals will always go somewhere from -1 to 1. If it's in the 0.1 range, well, actually, first let me tell you what these numbers mean. What these numbers are demonstrating is if I'm drawing my linear correlation, my correlation line, how accurately are my numbers clustering around that line? So like this first example that I drew, this first plot where they were right by the lines, that would have been a very high correlation because all these original ones that we talked about, they're all very close. They're not very far off the line. The more that I have going on away from the line, the weaker my correlation is going to get, the lower this number is going to be. So our positive or negative in front of our R is not referring to the strength. It's referring to the direction. So positive correlations will be a positive. Negative correlations will be a negative. So if I have 0.1 to about 0.3, that'd be considered low. 0.3 to 0.5 is considered moderate. And 0.5 and higher is considered high. But remember, the positive or negative does not matter as I'm evaluating this. A correlation of negative 0.6 is stronger than a correlation of 0.2. The negative is telling me the direction of the correlation. It's not reducing its strength. All right. So 0.1 low, 0.3 moderate, 0.5 and higher is higher, or the general thresholds that we consider as we evaluate the strength of the correlation. So this is what, let me make sure, check my notes, make sure I've covered everything about a linear correlation. All right, so this represents a linear correlation. I'm going to stop this here, reset the board, and we'll talk about what happens when you have scores that don't necessarily fall in a straight line, but we still know that there's a relationship there because that gets into a different kind of correlation.